You guys are doing okay on the last assignment, which is due today at 4 o'clock? I have had a lot of traffic this week, and I get a sense of how you guys are doing. With those I have interacted, but still it's a large class, and not everybody has been through my office. The next assignment, number 5, is already up on Moodle, which is due 1 week from today. And number 4 and number 5, assignment number 4 and 5, escalate the level of difficulty, okay, from understanding one line of code of what MATLAB does to putting these together to write functions and scripts. And in my lectures, I reinforce that idea by using scripts and functions to illustrate other features of MATLAB. And but at the same time, in number 5, for example, there are more engineering-related problems, a little bit more difficult than what you saw in assignment number 4. More like material that you are currently seeing in 2171, mass balances and stuff like that. And next week, I will put assignment number 6, which will give you an idea of what the exam will look like. Your exam is on October 30th, I believe. So 23rd, I will hand out the next assignment, the last assignment before the second midterm exam. Okay. So just to show you the pattern, and what I think you should be able to do right now, which you're trying out in assignments, is to write your own functions and execute them. But in an exam, second midterm exam, I'm not going to push you that far, but there will be one-liners like you had in the first midterm to reinforce what you have learned. And all the functions that are in what I call notes that I distribute on Moodle, you should be familiar with their role and their function and how to use them, what they will produce. So there will be one-liners based on that. If I pass this to this function, what will it produce? Okay, you should be able to respond to questions like that. In addition, for problem-based questions in the second midterm, what I have in mind is I'll give you a problem, and I will tell you that this is the code that solves that particular problem. But I will disperse a lot of errors in there, bugs. So your job will be to go through that code and say, okay, these are the things that are wrong I need to fix before I can run this and make it work. Okay? So in the exam, I'm not yet going to test you on writing a code. Okay? And this is a large class, so I cannot give an exam in a computer lab. Otherwise, ideal way of doing the final exam would be in a computer room where I give you a problem, you write the code, make it work, and submit your code. Okay? But since it's a large class, we're not going to be able to do that. So the final exam will be where you actually write a piece of code, but on a piece of paper, and I will evaluate whether that works or not. Okay? So that's the kind of expectation that I'm laying out for you down the road. Do you have any questions, comments, feedback? How many of you feel that you spent excessive amount of hours on assignment number 4? Whole class, wow! Keep in mind, the hours that you spent must be divided over 2 weeks. How many of you still feel that you spent excessive hours? So what hours are we talking about? 10 hours, 12 hours, 15 hours? Okay, but you must have learned a lot, right? The more time you spend, the more you learn. Right? You don't agree with me, obviously. Yeah?
Do you like curve or drop assignments? It's a valid question.
Do I curve or do I drop assignments?
Yeah.
I don't intend on dropping any assignments, okay? And I do curve. So I think the grade distribution that you will see is based on a normal distribution. Okay, so there are no clear cutoff points, meaning only if you get above 90, you get an A. No. Even if you get 75, the highest mark in the class is only 80. The top 25%, I guess, can expect to be somewhere in that range. So I do curve. Okay? So, but I must also tell you that you cannot take this and say, hey guys, let's uniformly lower our performance. Okay? What I do is I compare year to year. Okay, if this year, the whole class, I feel, this is why interaction is important to me because I make that judgment. This class I feel is better than the previous class. The average GPA for the class would be higher than the previous year. So I adjust that as well. Okay? So if this class is stronger, then you can expect the average GPA to be higher in the range of 3.2, 3.3 for the class average. But if I feel that you guys are not doing as well, then it might be 0.75, something like that. So everything is, the mean is adjustable. When I curve, I can fix all those things. Okay? So, but I try to give you the feedback of where you stand. The ranking is important, but don't feel that I'm kind of putting pressure on you. That's not the idea. The idea is to know where you are in the class so that you can redistribute your effort. If you're doing well in this class and you're struggling in another class, if you want to redistribute your time, that's fine. But if you're struggling in this class, you better put in more effort if you want to move up the rank. Okay? All right. Any other questions or comments? Assignment number 5, as I said, is on Moodle, so start working on it. And I'm not going to extend it because I'm going to give you another assignment next week, which will be the preparation for your second midterm exam. Now, today, in the last lecture, we saw a lot about debugging. Okay, are there any questions on that idea? Have you been using it in your current assignment? By only using these things, you get better at it. So the basic idea behind debugging is that you can take control of the execution. Okay, so you can set breakpoints and stop the execution there and step through it and trace where the errors are likely to be. As you are writing code, MATLAB gives you feedback on syntax errors and stuff like that. And they are typically highlighted. We'll make some mistakes today and show you those things, okay? And you should be able to fix that. And then when you're running it, if there are logical errors, the debugging tools, these are the commands that are very helpful for tracing where the bugs are, where the errors are. And the other thing I want to emphasize again is when you are solving a problem, your first thing is to understand the problem and identify specific tasks that you must do in the computer and break down those tasks and sequence them. If there is a task that's going to be used repeatedly, put them in a function with a well-known structure, with well-known input and output that will be called repeatedly many times to solve the problem. Okay? And write separate functions for those. And then write in a script or from a command line whatever you're going to call these functions to do the job. Okay? And again, I will illustrate it. Today we are going to focus on programming constructs like for loop and if condition, if then else. These two we are going to explore. And then I'll spend some time talking about one of the problems in your current assignment to see how to go about set up the problem, how to understand and set it up. Only one of the 3 problems. All the 3 problems are very similar in kind. So I'm going to use one problem to show you how to analyze it and how to structure it. Okay? So let's begin with the for loop. The general syntax of the for loop is, I guess I lost my pen. I didn't bring my pen, so I cannot write today. Okay? So the general structure of the for loop is you have a command that starts with for, the syntax, and then a loop variable. Okay? That's a variable that will act as a counter, how many times you want to do a certain thing. And equal to the range. The range actually tells you what is the range over which you want to repeat that task. So the for loop is extremely useful when you know beforehand how many times a particular task has to be repeated. Then you can set up that many times in the loop. And then what the actual action is, whatever you want to do the calculations, and then end it. So a for loop must have an end to indicate that is the end of the for loop, and all the actions inside that will be repeated as many times in the range using the loop variable as the variable counter. That's the basic idea behind it. Okay? So I want to illustrate that. I have put a piece of code if you want to print it and follow it, but when I'm illustrating it, I might depart from this, okay? Because I'm going to actually write the code, make mistakes, and try to understand. So interact with MATLAB in a live sense instead of just explaining what each code does. Okay? So let's go to MATLAB. So I'm going to write a script that's going to illustrate the application of the for loop. Okay? So I go to File, New, Script. Remember, a script and a function, the difference is script can contain any command that you can enter into a command window. Function file must have a well-defined structure with an input and an output, function as the first keyword. And then all the variables inside the function are treated as local variables, whereas anything that I put in the script is available in the workspace. Okay? So I'm going to put a comment, and when I put comment with 2% signs, it switches into something called the cell mode. So you can break down your script into several cells, and that might be something that you want to do. In the last lecture, because the recording stopped, am I recording now? I'm not sure. I guess I didn't. Okay, it is recording. All right. Okay, so when I put a person sign, it starts something called a cell. I illustrated this and how to produce a report. Another alternative to producing a diary output is a report, and which is very elegant. I just learned about it last week when I was playing with MATLAB, and I've illustrated how to do that in the last section of last lecture, which I recorded in my office. So if you haven't seen that, go ahead and review that, but we will see it again today. Okay. So 2% sign is still a comment. MATLAB will ignore whatever you put in here. Okay. So examples of for loops. Okay. And then I'm going to write a for loop for you. Okay. Counter illustration. Anything that you want to put as a command. Okay. And then for I equals 1 to 10, f print f, counter number is %g backslash n, end quotation, comma. What should I complete it with? I. You can see it in the notes. Okay. And that, and that. So we just wrote a very simple piece of code which sets up a for loop. Okay. What output do you think it will produce when I run this?
1 to 10.
Counter number is 1, counter number is 2, counter number is 3, one at a time, okay, in each line. So I save this and I give it a script file name. Let me go to my directory. Bear with me. I should have set this up beforehand. Docs, courses, oops, that's not the one I want. Okay, let me put it there. Okay, so I'm going to call this as test.m as a script file. Okay, so I have created a file called test.m, which is a script file, and that script file contains this piece of code. I want to run this code and see what it produces. So let me show you in the MATLAB workspace. I have nothing right now. Okay, so I go to the function file and I run this. So change the folder. Yeah. Okay, so it has run, executed that particular set of script, all the commands in that. So what did it produce in the command window? Counter number is 1, counter number is 2, counter number is 3, etc. Okay, that's a very simple task I set up inside the counter. Okay, any questions on that? Yeah.
Do you want us to use the script for submitting things in the future?
That would be a very good way of organizing it. I'm not enforcing it. As a design, I want to encourage that as a designer, you design the program any way that you want. There are easy ways of doing things. There are difficult ways of doing things. Okay, this would be for me an easy way of doing things, where I put all the scripts for various problems. In fact, after this assignment, you will see my solution. Okay, and that solution will show you one way of organizing your results. Right now, many of you have done a diary and then you have captured the figure and you zip all the file and send it. That's perfectly fine. Okay, I'm going to instruct the TA to accept that and give you full credit as long as there are no errors in there. Okay, but you need to collect all of them. You need to know how to zip the file, etc. Okay, so this report will make that easy for you. So we will review that today once again. It is in the lecture already in the previous one. Okay, any other questions on this? So we're going to explore looking at variations on this idea. Okay, so let me copy that and put part 2 as the title. And remember what happened. When I put 2% sign in part 2, this is highlighted. So this is cell number 2. So that is cell number 1. So anything that is between the 2% sign is treated as a cell, and you can execute the contents only in that cell by going to this part of the command and say evaluate the cell or control enter. If you do either one of them, it will evaluate only that part. So when you're debugging or when you're producing the result for first problem, you execute only that part of the cell. You get the output, you make sure that it is right, and then you go on to the next part of the problem. Okay. So here what I want to do is I want to put this. What do you think it'll produce? How many times will it produce? These are the kinds of questions you will have. In the second term, I have a code, and I'll ask you, okay, what does this do? Okay, how many times is it going to print? Now, you already know 1:2:10. That produces a vector. What will be that vector? 1, 3, 5, 7, 9. Right? And it will stop there because 10 is the highest one, but next one would become 11. So you understand the range, how the range works with the for loop. So it's going to print, if I save this and say execute only that cell, and then go and look at what is in the output. You see the output from here. Okay, 1, 3, 5, 7, 9. You get the idea, right? Any questions? Yeah.
Did you tell it to only run within that cell?
Yes, yes. Did it run this one, or was it from the previous output? Because I ran this first, right? That's a very good observation. Why do I see that output? Did it run the whole thing again? Very good question. So let's test that out and say, I say clear everything, and I say clear the command window, okay, and clear the command history. Everything is clear, blank. Okay. Now let's go and run that test again. Did everybody understand his question? When I point this in the second cell, if I press green, it will execute the entire contents of the script file. But if I go and press only this, it says evaluate only that cell. Okay. So if I do this and go and see the window, command window, I should see only that output. That's your question, right? Did everybody get that? So you can test one cell at a time. And ideally, what I would do is each problem would be a cell for me if I'm putting all the problems in one file to generate the output. Okay? So I'm going to continue to build a few other cells, putting variations on the stem to understand how the for loop works. Okay? If I don't cover anything specific, it may be in the notes that you should look at. So now I'm going to do this. 10 minus 1 minus 2, 5. What do you think it will do? How many times will it do? Can you see that? It's going to start at 10 and then 8, 6, 4 is beyond the range, right? So it should do 3 times and it should print these numbers. And I want to make sure that I make this as a part 3, the next cell. Okay, so I save this and I just execute that and go and find, you see here, that previous one was from the previous execution. It's still in there. Okay, 10, 8, 6. Now the next question that I could ask is, can it be a fraction? Okay, so I could go and say, for example, 0.21. The answer is yes. Your counter can be fraction. The variable I is actually used inside. It's available for use. In fact, we are using here just for printing, but you could also use it for doing calculations with it. Okay. So if I do this, what will it produce? 0, 0.2, 0.4, 0.6, 0.8, 1. Okay. So here I'm going to just save that and execute that cell. You can see 0, 0.2, 0.4, 0.6, 0.8, 1. Am I belaboring the point? You guys get it? Okay. Now let's look at a kind of a thought-provoking part of the question. What would happen if I do this 0 to 2 to 10, but instead of the task being this, I add a second task, that is I equals I plus 1. No, there is no way that you would know what it is, because you need to understand what MATLAB actually, how it interprets. But can you guess? By setting this loop, you are creating a loop variable I, and you are assigning a value of 0, 2, 4, 6, 8, 10, etc. But in here, you are saying I equals I plus 1. So what are you doing? You are changing that loop variable to? You add 1 to the index. In most languages, that would be a no, it will produce erroneous errors, because the next time it goes, maybe we should look at, let's just set up a breakpoint in here. I guess I need to save that. Okay, and let me run this to understand how the value of I keeps changing. Okay, so I have come to line 9 for the first time. What do you think the value of I would be at this stage? 1. So you take the cursor near and you find its value is 1. Okay, and when I step through it, it prints that line, goes back. Next time it will go back. What would be the value of I now? 3. Come on, I. Oh, it hasn't executed. It should be 3. Okay, so it will print 3. So you get the idea. Okay, it just keeps incrementing the value, and I'm not changing the value of I inside. In principle, a good practice is I should not change it. Okay, if I change it, there is a potential for getting confused, but MATLAB has a very specific rule. Okay, and that rule is what we are going to understand. Follow the demonstration and try to understand it. Okay, so what will be the value of I? 0, right? That makes sense. What will be the value of I? 1. That makes sense. So what will it print? 1. When the counter is 0, it will print 1. Okay? And did it print 1? Let's go back and see. It did, as we expected. Okay? Now, I'm going to step one more time. What do you think the value of I would be? Will it be 2 or will it be 3? Because we changed it from 0 to 1. When it goes back, what does it do? Well, let's go and see. It resets it. Okay? MATLAB allows you to use it in your computation, and if you reassign it, it will use a reassigned value within that loop. But once it comes back to the beginning of the loop, it erases that value and resets it to what it determines it to be in the first position. So from this interpreting that line, it knows that it needs to set the value of I to 0, 2, 4, 6, 8, and 10. So whenever the loop comes back, it resets it. So which is nice for you, but you need to understand that's what it does. Okay? So the value of I is 2 now. Is it clear? Does everybody understand that? What will be the value of I now? 4. Right? But the next line, it will become 5. So it will actually print 5. Okay? Prints 5. But when it goes back to 6. Okay? So these are the rules about the for loop. You can specify the range in any way you want, and you can use the loop counter variable for your calculations inside the loop, but when it comes back, if you change it, it will reset it to the next value in the sequence that it determines at the beginning. Okay, any questions on that? Yeah?
I'm still a little fuzzy why it increments 1 and then it skips 2 and then increments 1 and skips 2 and does it again. I don't understand that.
Okay.
I mean, what my logic would be is it starts at 0, you add 1, I would be 1. Then it goes to, uses that 1 value, adds 2 to it, and then adds
It does not use that 1 value and add 2 to it. It goes back to 0 and adds 2 to it. Maybe because I used 1, it's confusing, so let's change it to 5. Okay? Now let's trace it once again. Okay? Oh, I don't want to set the breakpoint there. I want to set it there. Okay? So now what is the value of I? 0, right? So now what is the value of I? 5, right? 5. Okay? And it will print 5. And when it goes back, it resets to 2. You understand that? Anybody else?
So it resets to the value of the first one. And then adds.
It resets to the value that it determines when it figures out. When it comes here, it figures out how many times do I have to do, what are the values. And it resets to that list. But you can use that variable any way you want inside, change it, but when it goes back to the original set of numbers that it figured out. Is that clear to everybody?
So you're just, when you hit the button at the top, you're just saying run this line, then it takes that value, runs it on the next line.
Yeah.
Then it will print it out, as you told it to print out the previous answer, and then when you go back up to the top, it resets.
Resets it, exactly, right. Okay. The beauty of this debugging, I'm using the debugging feature to illustrate line by line as it executes. Okay. But I could, for example, take this, save this file, go to the command window, because this is a question that many people have had. How do I execute this particular script? Okay. So let me show you how to execute the script and how to produce the report from there. Let me just stop the debugging right now. Okay. So I am in the command window. I've written a script which is called test.a. So let me type test. I guess test.m. Okay. So these are the commands that I wrote. I made the fonts bigger so that people at the back can see it, but it doesn't fit. All of it doesn't fit here. Okay. But that's a script that we wrote. To execute all the contents in that script, all I have to write is type test, the name of the script file. Okay? It will run through the whole commands in that script file and execute one by one. Okay? That's one way of producing it. Another way of producing the output is, this is an important thing for handing the assignments. Okay? You can go to, next to the printer, there is a report generator icon. So you say publish that script. And when you do that, it opens up a form and it says, okay, in what format you want. So you can select a doc format, which is the Word document, or a PDF, or HTML, if you know about these things. But pick normally doc, Word document, so that you can edit it. Okay? And then say publish. When you say publish, what it does is it executes all the commands in the script file, captures a copy of the script file, the code, the output, and any graph that you generate, it will also put it into the report. So you get one file containing all the output in a very beautiful form. So you can just submit that. Okay. So let's just wait to see what it produces, and I will show you that file. Well, it has to open the Word because there it is. Okay. Examples for loops. These are all the commands that I put. Okay. Part 1, part 2. These are used as the heading. 2% sign followed by something. It is used as a heading. So here is a major heading there. Okay. And then you actually see the code. This is the first cell. Okay. Nicely boxes it, puts the code, and when you execute it, what is the output? The output is this. Counter number is 1, counter number is 2, etc. That is the output produced by that code. Okay? And then followed by the second part, it could be your second problem, the piece of code. Okay? And if you call another function, I would say put a type that function so that the function is also listed and a copy of it will appear in the output. Okay? And the output from that, and part 3, the code and the output from that. If you had a figure, for example, let me just close this and put a figure in there. Let me create a figure. Okay. percent illustration. Oops. plot. So x equals 0.1 to pi, y equals sine of x, and plot x comma y. So I'm creating a vector on the x-axis and calculating y to be the sine of that, and I'm saying plot. Okay. So if I want to execute only this to see whether it works, I execute that cell, and there is your sine function, a graph of that. Okay. But if I want to produce a report, I go and select that, and it means, I've selected it to be the doc, and I say publish. So it creates the graph and puts the graph into your output file, the doc file. Do you understand the idea of report generation? Does it help you in structuring your assignments?
Where was it found out?
Pardon me?
Where was it found out to make the page?
When you are in the editor gives you a set of icons on the top. These are all debugging. This is for execution. But next to the printer icon, there is a report icon. You press that and edit publish. You select that, and then you'll be able to publish. Yeah?
If I submitted my thing before I knew about this publish thing, but I just did it as a Word document where I copied all
That's perfectly fine. As I said, you can choose to use any method that you want to produce the output. Okay? I would like people to be kind of creative and use your own techniques and show me, I guess, that you are comfortable with programming, handling zip file. In fact, that's in the sense of learning new things, that's probably better for you. But this is a quick way of organizing the results and getting the report out. Okay, and I'm looking for the output doc file. So here it is, illustration of plots. There is your graph at the end of it. This follows that section of the code, illustrates the code, what code it executed, and then what output it produced. Okay, it's a nice feature, I think. So you might benefit by using that. Any questions on that? Yeah.
Yeah, I understand that, but the part that confuses me is whenever there's more than one variable to account for the for loop.
Okay. When more than one variable in the for loop?
Yes, to account for.
Okay, let's go back. In fact, I had one thing as an illustration. I forgot to do that. Let me add that to that. Okay. Let me, in fact, delete this. Part 4. I'm going to illustrate here nested. Is that what you mean? Nested loops? I'm not sure exactly what you mean. See whether this is the one. Otherwise, I will ask again. Okay. Nested loops means you want one for loop inside the other. You can nest any number of for loops depending on the task that you have to do. In fact, I will illustrate this with one of the examples that you have. Okay. The example that you have in the finance problem. Okay. You have a formula and you're asked to calculate the total value based on the principal and the interest and the number of years. Okay. So let me first write a function. This is going to be actually answer to that particular problem. Let me delete all this. Function t equals finance p comma I comma n. Okay, and t is equal to p times 1 plus I dot to the power n. End. So what does this function do? It accepts one value of p, one value of I, and a vector of values of n, and returns the corresponding values of t. So this is the isolation of the task. This is a task that's going to be used repeatedly because I want to do this calculation for 2 interest rates and 10 different years. Okay? So there I have a natural illustration of for loop. Many of you have come to my office and I've told you how to do it a different way. But this is another way of doing it. In programming, there is no unique way as long as you get the task done. Okay? So I save this function and I go to my script file. And in the script file, I set p is equal to 10,000. Okay? I is equal to a vector 0.030.06. Okay, and n is a vector 1 to 10. Now I need to calculate. Now don't use this as a solution for your current assignment because I'm not going to format the output. I'm just going to illustrate how to calculate the 20 different t values. Okay, so I is going to increment, okay, to 2 values, and n is going to increment to 10 values. Okay, so for k is equal to 1 to 2, for j is equal to 1 to 10. So I've set up 2 loops, one inside the other. One loop goes for 2, that's a loop I'm going to use to change the interest rate. The other loop goes to 10, that's what I'm going to use to change the number of years. And then I put the statement t is equal to finance p, comma, ik. Why ik? Because I contains 2 numbers and I want to do it 2 times. When k equal to 1, I wanted to pick the first number 0.03. When k is equal to 2, I want to pick the second number 0.06. And I'm going to do the same trick for p. Okay. So what should the index for p? For n. What should be the index for n? J. Very good. You guys are doing well. Okay. And end that, and end that. So here I have, and this is called a nested loop. Okay. For each value of k equal to 1, that is interest rate of 0.03, the inner loop will be executed 10 times. Each time sending one value of year and getting the output. Okay? And then it will increment to the second time. So let's set up a breakpoint and see how the flow is. Do you understand what I'm trying to do here? Is that your question? Is that?
Yes, but I have a quick question.
Yeah.
For I and n, since they're different lengths,
Yeah.
does that affect it since you put it all
In this one, it will not affect. But when you have to format all the output the way that I asked in the assignment, it will matter. You need to do this in a particular way. So here I'm focusing on, I'm not giving you the solution to that particular assignment. I'm focusing on how to illustrate, how to do that nested for loop. So what will happen is every time it goes to that finance function, which is repeatedly used 20 times in this loop, it will come back with the number t. But that t will be continuously overwritten. Okay, let's look at that. So I set up the script and the script has stopped here. So what is the value of k? 1. What is the value of j? 1. Okay, and let me also set up a breakpoint inside that finance function to show that it will come in here 20 times, each time with a different value. Okay, so when one function is calling another function, or one script is calling another function, which calls another function, etc., you can actually set up breakpoint and trace the flow of execution. So it's a very powerful tool in that sense. Okay, so let's go back, and I'm going to step one line at a time. Now I know k is 1, j is 1. Okay, so control has gone to finance. From that script file, control has been shifted to finance. I want to ask you the question, what would be the value of p, I, and n in this instance? P would be 10,000. What would be I? 0.03. Why is it 0.03? Because k is 1. When k is 1, I of k is I of 1, which is your first entry here. Okay? So, what would be n? N would be 1. N is a local variable here, whereas n is set up in the workspace, and n here is how is it only 1? It must be 10. Well, okay, that's a good, just occurred to me. Why is it showing the value of n as 1? Because in the workspace, currently it shows only the variables that are local to that function. So here, p, I, and n are local to that function. I'm inside that finance function. So there's only one value. Okay? But let's trace that and see what happens when I get out of that. Okay? Are you following me? Am I going fast? So I'm going to step. When I step, it's going to calculate the t value, only one value. Okay? That's 10,300. And the control will go back to the script file where it came from. So there is a control. Okay? So it returns the t value here. But what is the value of n now? Because I'm out of that function, that n local value has been erased. It's a very good illustration of what the local variables are. If I point to n now, it shows me all the 10 values. So at this function or in this script, n is defined to be 10 values. Very important that you understand that. Okay? So now it goes back. What will be the value of k? Still 1. Okay? Because it hasn't gone to the outer loop. It is doing the inner loop. What will be the value of j? 2. No, I have this bad habit of moving on when one person answers the question because I assume everybody understood it. If you don't understand, please put up your hand and ask me to explain it. Go through the tracing one more time. Okay? So, now, did I remove the breakpoint in the finance? I guess I did. Okay? So let me set the breakpoint and go through that. So what is the value of I? 0.03. What is the value of n? 5. In the inner loop, it has done 5 times. Okay? So the value of j there must be 5. I guess it's not showing because I'm not in that function. Okay? So execute, come out, and look at j. J is 5. So are you guys following? You probably need to replay this if I'm going very fast in the class. Okay? But for those I'm boring you to death, please tell me, then I can speed up. Any questions? So let me take the breakpoint, and then continue the execution. So it would have executed 20 times, but it will set only one t value because I am rewriting it. So I'm not answering the question of how to format the output for your assignment. That you need to figure out. But here I'm illustrating how the nested for loop works. Does that answer your question? Any other questions? Nope? Okay. Let's look at the next part of the lecture, which is if. Okay, the if condition. So this is an important construct also for controlling the flow of the program. What is the general syntax? If a certain condition is met, do all these actions. Else, that is, if that condition is not met, but you have another condition, you say if that condition is met, this is optional, you don't have to have that. Then you have a second set of condition. So this is conditional execution. Execute the following set of code only if a certain condition is met, and then continue to build that. So let's see the illustration of this in another script file, or maybe continue on to this. Okay, if then else illustration. Okay, so my task is going to be, there is a function called rand in MATLAB. Okay, and what does that function do? It generates a random number between 0 and 1. If I ask for help on rand, it tells me that it produces a random number that is uniform in the range 0 to 1. Uniformly distributed pseudo-random number generation. What does that mean? It means that the probability of getting a number between 0 and 1 is equal. So if I do a following test, I want to see how many times do I get below 0.5 and how many times do I get above 0.5 by calling this random function repeatedly. What do you think the answer should be? 50-50, right? 50% of the time it should come below and 50% of the time it should come above. So I'm going to test that hypothesis by writing a code. Okay, I'm running out of time, so if let me set a for loop first. For I is equal to 1 to 1000. So I'm going to do 1000 times, repeat this experiment 1000 times. Each time I'm going to check whether the number is less or greater than. So if rand is less than 0.5, then I'm going to set up a counter. Count equals count plus 1. Okay, end if, and then I'm going to say fprintf, print out the result. Okay, fprintf number of times less than 0.5 is %g \n quotation mark, and I'm going to divide this count divided by 1000 and then end it. Any question on the code? Do you understand it? I'm setting the experiment 1000 times, sorry, and each time I'm picking a random number and I'm asking the question, is the random number less than 0.5? If it is, increment the counter. Will this code work? This is the kind of questions you'll have in the exam. Will this code work? No. Why not? Because the end statement is there for both the for loop and the if loop, but the first time it comes to line 31, it will say count equals count plus 1, but I haven't defined what count is. Count is a variable where I'm counting how many times this condition has been met. So I need to initialize the count. I need to put count equal to 0. So the first time it's 0, and then whenever it's less than 0.5, it goes through that loop, it increments it. Okay? So save that and run it. Not run it, I guess run only that cell. So let's see what the output is. What did it say? 0.482. Does that result make sense? What did I actually calculate and output? I counted the number of times the number was less than 0.5 and divided by the total number of trials. Okay, 1000 times. So 48% of the time it was less than this. But I expected 50. Okay, why is that? Why is the difference?
Percent error.
Pardon me?
Is there like a percent error on that?
It's not a percent of error. That fraction should go towards 0.5. Yeah. Not enough trials. Those who know the statistics would know. I don't have enough trials. For example, if I do it only 100 times, that number would be even worse. Okay, so save that and run that particular cell and look at the result. It's 0.46. Okay, but if I increase the number of trials, oops, okay, to 1,000,000. Okay, save that and run that. It should converge towards 0.5. It's doing 1,000,000 times. I shouldn't have. When you get into this, Control C will get you out of the loop. Okay. What was the problem? The problem was I didn't put a semicolon there. It is printing every time. In fact, I should put it outside that loop, okay, because I just want the output at the end. Okay, so this is how you make trial and error developing the program. If you get used to that, you'll be doing fine. Okay, any questions on that? I have two other variations on this code, and one is wrong. The other one I fixed as a correct implementation. There I'm asking the question, how many times does it occur between 0 and 0.2, 0.2 and 0.4, 0.4 and 0.6? I'm increasing the number of bins. So each one should occur 20% of the time. Okay? Go through that code, try to understand it, and that's how you learn. Whatever we cannot cover in the class, we must pick up on your own. Okay? Stop there.